Hi, I'm Regina, and I'm from UCSI University of Malaysia. And currently, I'm a postgrad student study on the significance of Kappa-carrageenan that to be used as biocomponents for sustainable bioproducts and byproducts. So today, I'm going to present my title, The Innovation of Kappa-carrageenan, Encapsulating Magnetite Nanoparticles in Removing Heavy Metals from Wastewater. So this is the overview of my presentation today. So as we know, the pandemic has posed a global challenge to our country and the community, which alerts us the importance of good personal hygiene and good water quality. So the environmental pollution, especially the heavy metal contamination, has been well concerned. So good water quality are indispensable to conserve our environment health. And most of the heavy metals come from the industrial and technological activities which ended up into our aquatic ecosystem. And these metal ions can actually bioaccumulate in the aquatic organism, which further bioaccumulate to higher trophic level of the living organism, including human. So the effects of heavy metals posed to humans are brain damage, coronary disease, anxiety and depression, tubular damage in kidney, lung damage, as well as lung cancer and some stomach cancer. So to address this issue, adsorption was suggested to be the most potential application in wastewater treatment, which provide high removal rate and easy operation. So nanoparticles are usually used in adsorption activity due to their nano size that add with the removal rate. And magnetite nanoparticles has been proved in ability to remove heavy metals such as cadmium, chromium, nickel, and copper ion. And besides, seaweed Kappa-ficus avrasi had been proved with absorption ability of water contaminants in wastewater bioremediation. Hence, this study aims to evaluate the efficiency of magnetite nanoparticles, adsorbent, surface modified with Kappa-ficus avrasi-carrageenan in removing heavy metals from wastewater. So firstly, we'll go into the methodology. So we will carry out co-precipitation of iron 2 chloride tetrahydrate and iron 3 chloride hexahydrate to form the magnetite iron oxide. So chemical precipitation was achieved by adding the sodium hydroxide. Then the yellowish mixture will turn into reddish brown solution, then converted to black suspended particles. Then after dry, the iron oxide powder will be added with distilled water to form 2,500 milligram per liter and adjusted to pH 3, 5, 7, 9, and 12. So in this case, the iron oxide is positively charged. Next, we will prepare the Kappa-carrageenan extracted from Kappa-ficus avrasi and adjusted to pH 3, 5, 7, 9, and 12. So in this case, the Kappa-carrageenan will be negatively charged with sulfate group. Then surface coating of magnetite iron oxide with Kappa-carrageenan will be done by sonication. So the Kappa-carrageenan will encapsulate the iron oxide by electrostatic attraction. Lastly, the magnetite Kappa-carrageenan iron oxide absorbent will be used in wastewater treatment to determine the capability in removing copper ion. So we will set up the experiment design as shown in the table with different pH of Kappa-carrageenan iron oxide absorbent and measured for the absorption capacity as well as the percentage of copper ion removal. So after testing for 2 weeks, the copper concentration in the wastewater significantly reduced when the absorbent was added. So we can see from the figure on the right, the color of the copper ion reduced from dark blue to light blue for each different pH of the absorbent added, but the control without the absorbent remained unchanged. So from the figure, we can see K2 with pH 3, the color was the lightest in the treatment. So the comparison between initial and final copper concentration can also be observed from the graph. So the K2 with pH 3 show the lowest copper ion concentration after treatment with only 0.1 milligram per liter, and the control treatment without the absorbent remain unchanged, which is 1 milligram per liter. We also can measure the absorption capacity from the treatment. So K2 with pH 3 show the highest absorption capacity of 2.97 milligram per liter compared to the other pH 5, 7, 9, and 12. So pH 3 is the highest because the iron oxide is positively charged, and the Kappa-carrageenan is negatively charged, so they will bind nicely by electrostatic attraction in pH 3. And we can also see the absorption reduced in pH 5. So this might be because of the positivity of the iron oxide reduced. So the ability to attract the Kappa-carrageenan also reduced. Hence, the absorption capacity also reduced. But there's a sudden increase in following pH 7, 9, and 12. So this might be because of the copper ion self-precipitated after forming the copper hydroxide in the alkaline solution. Thus, we suggested that pH 3 is the most suitable pH in coating the iron oxide with Kappa-carrageenan. Next, we will move to percentage of copper ion removal. So the Kappa-carrageenan iron oxide absorbent with pH 3 remove the copper ion with 90% of removal rate, which further proving that this developed absorbent offers the ability with high surface area that can enhance the copper ion absorption rate. Also, this absorbent has high recovery rate, which can be reused in the next absorption treatment. However, further research will be carried out to recollect the absorbent and Kappa-carrageenan from the wastewater for desorption treatment. So from this study, we want to conclude that the innovation of Kappa-carrageenan iron oxide absorbent was suggested to be effective in removing heavy metals from wastewater with high removal rate. And Kappa-ficus avarezi has been proved to be effective in removing heavy metals and dyes from wastewater. And we want to emphasize that a good water quality is essential in our daily lives, which provide us a safe and healthy water source to our community and the environment. And that's all from me. Thank you.